Before analyzing these mechanics, a brief medical disclaimer. Consult a certified training professional or physician before initiating high-intensity regimens. The burpee is a multi-joint calisthenics exercise that links a squat, a plank, a push-up, and a plyometric jump. This specific sequence requires the body to manage both aerobic and anaerobic energy demands simultaneously. This alternating mechanical demand requires a continuous transition between rigid midline stabilization and explosive power output. In doing so, it recruits almost every major muscle group in the human kinetic chain. Shifting the body through these planes of motion creates a high-density workload, requiring the cardiovascular and musculoskeletal systems to respond to near-simultaneous demands. The movement was established in 1939 by applied physiologist Dr. Royal H. Burpee as part of his doctoral thesis at Columbia University's Teachers College. While serving as the executive director of a YMCA in the Bronx, Dr. Burpee sought to devise a rapid physical capacity test to evaluate the baseline coordination and agility of new members. During World War II, the United States military adopted the movement to assess the cardiovascular efficiency and coordination of incoming recruits. Dr. Burpee's original sequence provided a repeatable metric for assessing the heart's efficiency and relative body weight strength, benchmarks that remain standard in metabolic conditioning today. This biomechanical breakdown begins with the rapid descent and push-up phase. The pectoralis major and anterior deltoids undergo significant eccentric loading to control the body's descent, immediately followed by concentric contraction of the chest and triceps to press the torso back up. In the plank transition phase, the body relies on immediate engagement of the core musculature. The RectusAbdominis, transversus abdominis, and obliques fire isometrically to stabilize the pelvis and counter gravitational forces pulling the lumbar spine toward the floor. Failing to maintain this isometric brace leads to lumbar hyperextension, placing stress on the lower back and causing mechanical breakdown. Before any explosive vertical movement occurs, the athlete must coordinate the anterior chain to maintain structural integrity under dynamic gravitational load. The transition out of the plank requires the Iliopsoas and RectusFemoris to activate, snapping the lower limbs forward into a crouching squat. From here, vertical liftoff relies on concentric triple extension. The GluteusMaximus, Quadriceps, and Gastrocnemius fire to drive the body upward. This plyometric jump taxes the neuromuscular system, demanding immediate fast-twitch muscle fiber recruitment and spatial proprioception. This sequence creates kinetic chain exhaustion by linking isolated eccentric, isometric, and explosive concentric contractions into a single fluid cycle. We can contrast the systemic kinetic chain demand of the burpee with a highly isolated movement like the barbell hip thrust. A 2019 Journal of Sports Science and Medicine study demonstrated its mechanics favor extreme, isolated activation of the hip extensors. This degree of isolation is optimal for maximizing localized muscle hypertrophy and generating post-activation potentiation. The burpee, conversely, prevents localized isolation. Its structural design distributes the mechanical load across multiple joint systems at once. While isolated lifts maximize local tissue mass, the burpee is designed for systemic structural resilience and total whole-body power output. This is a graph tracking cellular energy demands. When muscle groups are repeatedly taxed during high-intensity intervals, the internal physiological environment shifts. Executing multiple repetitions depletes localized ATP stores, forcing the body to transition its metabolic engine into anaerobic glycolysis. This energy demand creates an oxygen deficit. To clear metabolic waste, the cardiovascular system must rapidly increase heart rate and oxygen uptake. Research from Barfield in 2014 and Pearson in 2023 indicates that CrossFit-style programming centered on the burpee significantly increases a practitioner's VO2 max. The heart increases its stroke volume to pump more blood per beat, while cellular tissues adapt by increasing mitochondrial density. The burpee acts as a cardiovascular hyperstimulus that upgrades the body's oxygen utilization engine. After a high-volume burpee interval, an athlete typically experiences heart rate levels near their absolute maximum, high lactate accumulation, and heavy respiration. This graphic displays the state of excess post-exercise oxygen consumption, or EPOC, commonly known as the afterburneffect. Because the movement engages such a large percentage of total skeletal muscle, it creates a metabolic perturbation that requires elevated oxygen consumption for hours to return the body to homeostasis. By combining rapid ATP depletion, heart rate spiking, and epoc triggering, the burpee serves as an efficient tool for targeting the entire kinetic chain. Future episodes on Insight Engine will explore advanced variations of this movement and trace their specific adaptations for endurance athletes. We will also deconstruct the biomechanics of the burpee deadlift couplet, examining the physiological adaptations that occur when cardiovascular strain meets heavy axial loading. This specific exercise pairing creates sagittal plane balance by alternating intense anterior and posterior demands. Like this video and subscribe to Insight Engine for more research-backed deep dives into biomechanics and physiological programming.